Okay. Waves and normal modes. So first of all, we will study what is a standing wave. Then we will study about normal modes in different cases. Okay. So side heading standing wave. Standing wave. Okay. Just imagine you have a system or you have a stretched string. You have a string. You are stretching the string on both ends. Okay. When you make a vibration here, what will happen? That vibration will go till this end. After that, what will happen? From this end, it will reflect back and go like this. Okay. So basically, you have a wave moving from left to right. No, what? Right to left and left to right. You have two waves. Okay. One wave is from right to left and another wave is from left to right. Okay. And when they both superimpose like this, or one wave in from right to left and one wave from left to right, when they undergo superposition, standing wave is produced. That is standing wave. Understood? Standing wave. Okay. So write that. When a system is bounded by two ends, when a system is bounded at two ends, when a system is bounded at two ends, when a system is bounded at two ends, then the waves from right to left, then the waves from right to left, right to left, and left to right, and left to right will move until a steady pattern is set. So waves will move from right to left and left to right until a steady pattern is set. These waves are called standing wave or stationary wave. These waves are called standing wave or stationary wave. These waves are called standing wave or stationary wave. These waves are called standing wave or stationary wave. Done? Done. So let the waves are given by, let waves are given by. Left to right wave is y1. What will be the equation left to right? Equation of a wave. Equation of a wave. What was the equation of a wave? A sine kx minus omega t or plus omega t. Positive wave. Left to right means it's a positive wave. Minus, right? So y1 is a sine kx minus omega t. So if the wave is from left to right, that is in positive x-axis direction, it will be given by minus omega t. Now y2 from right to left, that is a negative wave. So what will be the equation? A sine kx plus omega t. So these are the two waves. Okay, when they are moving together, superposition will happen and a standing wave will be produced. What will be the equation of a standing wave? Just add these two, like we did in superposition principle. By the principle of superposition principle, we have the combined wave as. By the principle of superposition, by the principle of superposition, the combined wave is given by the principle of superposition, the combined wave is given by y is equal to y1 plus y2. It is equal to a into sine kx minus omega t plus sine kx plus omega t. What is sine a plus sine b? Last class we did. What is sine a plus sine b? Sine a plus sine b. What is it?
2 sine A B.
Eh?
2 sine A B by 2.
Huh?
A plus B.
A plus B by 2 times
Divided into cos
Cos
minus
a
B by
minus
2.
b by 2. That is the formula. So you have sine a plus sine b. Apply this formula and write what you are getting. Apply sine a plus sine b formula and write what you are getting. Yes, Simon. Done. What you are getting? Sine a plus b by 2, kx by 2 to cancel. Minus omega t will be gone. So sine kx, right? 2 sine kx cos minus omega t, right? Kx gone, minus omega to minus 2 omega t by 2, 2 cut. So minus omega t. What is cos minus theta?
Theta. Cos theta.
Cos theta. Cos minus theta is cos theta. So it will be 2a sine kx cos omega t. That will be the equation for a standing wave. Understood? Okay. When a wave in the positive x-axis direction undergoes superposition with a wave in the negative x-axis direction, standing wave is produced, and this is equation for standing wave. Now in this, can you tell me what is the, okay, this much finished. So this is equation for standing wave. Now tell me, what will be the amplitude of this wave? What will be the amplitude part? Now,
Amplitude, it would be k x.
amplitude.
Then that will be 2a plus x.
What will be the amplitude?
Just 2a.
2A.
2a plus.
See, here the amplitude will be given by 2a sine kx. That will be the amplitude.
2a.
That will be the amplitude. Okay. Here, how will you identify? Theta is omega t, right? So cos theta, that is the varying part. So when two sine waves of this type superimpose, you are getting a cos wave. That is the meaning. And the amplitude of that cos wave is this much. Understood? Okay. So write the amplitude of the standing wave. The amplitude of the standing wave is given by 2a sine kx. Standing wave is also known as stationary wave, okay? Both are same. Standing wave and stationary wave are the same. So amplitude is given by 2a sine kx. Amplitude is given by 2a sine kx. Done, right? Okay. Now, that much is okay? Okay. Now we studied what are nodes and antinodes. What are nodes?
Nodes are the minimum.
Position with a zero amplitude is node. Position with the maximum amplitude is antinode. Okay, now this is the amplitude equation. So minimum amplitude means this will be zero, right? Node means minimum amplitude. Okay, that means this will be zero. So case 1. Case 1 for zero amplitude. That is for getting nodes. So what will be that? 2a sine kx will be equal to 0, right? Now, can 2a be 0? Can 2a be 0? Can 2a be 0? What was the equation? What is a? 2 can never be 0. What is a? A is the amplitude of y1 and y2. It can never be 0, right? If it is 0, there is no wave. If amplitude is 0 means there is no wave. So what was the equation for y1? Y1 was a sine kx minus omega t. Y2 was a sine kx plus omega t. So a can never be 0. So 2a can never be 0. So here what can be 0? Sine kx. Okay, for amplitude to be 0, 2a can never be 0. Sine kx can be 0. So you can write here sine kx is equal to 0. So which all values of sine theta is 0? Rohan, are you there?
Yes.
Yeah, which all values of sine you have 0 value?
90.
Oh, sine 90 is 0.
90, 0, 0.
Sine 0 is 0 then? Sine 0 is 0 then?
360.
360 is 0 then? One eighty is 0. Okay, so basically multiples of pi is 0. Multiples of pi. 0 into pi is 0. 1 into pi is 0. 1 pi is 180, right? 2 into pi is 0. 3 into pi will be 0 like that. So how can you generalize? If the value of theta is n pi, sine will be 0. Understood? So what you can write? Therefore, kx will be equal to n pi. Understood what we are doing? This you understood. Okay, for values of sine, multiples of pi, you will get value of sine as 0. So therefore, what you can write? Therefore, kx will be equal to n pi. Our aim is to find x, okay? Our aim is to find x. X is the position of node. You're going to find which all positions node you are getting a node. That is what you're finding. Okay, so kx is equal to n pi. If you have doubt in this, show this in the for your reference. Okay, you can note it for your reference. So here n is what? N is 0, 1, 2, 3, etc. Okay, now x will be what? N pi by k. What is k? What is k formula? Again, what is k formula?
K is n by x.
K formula I gave already. 2 pi by lambda. Wave number 2 pi by lambda. So you will substitute that 2 pi by lambda. Pi cut L lambda by 2. Okay, so what you are getting? Nodes you will get it as N lambda by 2. What does that mean? If you draw a wave, put n as 0, what you will get? X equal to 0. Then n as 1, you will get lambda by 2. X is 1, you will get, x is 2, you will get lambda. X is 3, you will get 3 lambda by 2. X is 4, you will get 2 lambda. So these are the positions at which the wave is becoming 0. These are the values, or these are the positions at which the wave becomes 0, or these are the node positions. Understood? Understood all of you? Steve, you understood. Ayman? Okay, so you're finding, your aim is to find the position of nodes. Okay, you got the amplitude equation. From there, you are finding the position of nodes. Okay, so for that, node means amplitude is 0. So 2a cannot be 0, sine kx is 0. The position of node is given by x. Okay, so kx will be n pi for sine to be 0. And then from there, you will get x is equal to n pi by k or n pi by 2 pi by lambda or n lambda by 2. So for substituting n as 0, 1, 2, 3, you will get x as 0, lambda by 2, lambda 3, lambda by 2. Understood then? We draw this graph also, okay? So these are the positions at which, these are the positions of nodes. Here you can write, this is the position of node. Position of nodes. Okay, done? Now next we will do case 2 for maximum amplitude. Maximum amplitude is what? Antinode. You will be finding the position of antinode as well. Finished? Okay, finished, right? Now next. Case 2 for maximum amplitude. For maximum amplitude. For maximum amplitude, that means it is antinode. Maximum amplitude means it is antinode. So, what will be sine kx? For maximum amplitude, what will be sine? What's the maximum value of sine? 1. Okay, maximum value of sine is 1. So, for maximum amplitude, sine kx should be equal to 1. So, for which all values of sine, you will get 1. Pi by 2. 3 pi by 2. 5 pi by 2. So, all odd multiples of pi by 2, you will get sine as 1. Okay. So, for getting odd, what you will do? Kx will be equal to n plus 1 into pi by 2. Will that work? 2n plus 1 pi by 2, will that work? You put n as 0.
1.
N as 0, you will get pi by 2. N as 1, you will get 3 pi by 2. N as 2, you will get 5 pi by 2. So, this will work. Okay, understood. So, this will be the general formula. From here, you have to find x. X is equal to 2n plus 1 pi by 2 by k. So, k is 2 pi by lambda. 2n plus 1 pi by 2 by 2 pi by lambda. Pi cut. Lambda by 4 will come. So 2n plus 1 lambda by 4. So what you are getting? X is equal to 2n plus 1 lambda by 4. What does this mean? These are the position of antinode. This will give you the position of antinode. So when you draw, so put n as 0, what you will get? Lambda by 4. So first antinode will be at lambda by 4. Now n as 1, what you will get? 3 lambda by 4. Correct, right? 3 lambda by 4. Put n as 2. 5 lambda by 4. Correct?
Yeah.
Okay. So these are the positions of antinodes. Understood? Everyone understood? Rian. Okay. Complete that. Finished, right? Clear? Is it okay? Okay. So that's all about standing wave. Okay. Standing wave is only this much. What is a standing wave? How is it produced? How is it produced? When a stretch in a stretched string, when a wave moving from positive x-axis direction and a wave from negative x-axis direction superimposed, a pattern superimposed and a pattern will be produced. That pattern we call it as a standing wave. Okay. And in standing wave, the position of nodes and antinodes, that is what we studied. This is an important question, okay? Now next you give heading normal modes. Give heading normal modes. Normal modes, MODES. Take your textbook also. Normal mode. See, all of your textbook? That is 40. You have? Those are online. I'll share the screen. Okay. Okay. Keep it with you. Okay. Now listen. Listen. So when a string is stretched, the waves produced, we call it as standing waves. Okay. And these waves will vibrate only in certain patterns. You know, in a guitar and all, each string, there is a different sound is produced. So each string, the pattern will be different. Okay, depending upon how you how you put the striker, the sound will be different. Okay, so that we call it as different modes. Okay, so there are different modes. The pattern produced by a standing wave, different patterns in a standing wave, we call it as different modes or normal modes. Okay, so give side heading normal mode. Below you write, when a string is producing standing wave, 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 it vibrates with some definite pattern. It vibrates with some definite pattern. It vibrates with some definite pattern. And these patterns are called normal modes. Normal modes, MODES. And these patterns are called normal modes. Okay. So this year you have to study the normal modes produced in 3 cases. First case on a stretched string. The modes in a stretched string. Then closed pipe. Closed pipe means one side is closed, the other end is open. Just imagine a tube. Like the tuning fork experiment, you have a tube with one end closed. Okay, that is called as a open tube. Sorry, closed tube. Okay, next is open tube. Open tube means a tube with both ends open. So you will be studying the patterns or the modes produced in these 3 cases. Okay, so first one you give side heading. Normal mode on a stretched string. That is the first case. Normal mode on a stretched string. Normal modes on a stretched string. Normal modes on a stretched string. So you can copy the diagram in the textbook. I think figure 14, I think. 14.13. If it's this figure, you have to copy. All the 6 cases you have to draw. Before that. 13. Figure 13. That one. Yeah, that one. See? It should be, the length should be the same, okay? It should be the same length. You should not draw one this much length, the other this much length. The length should be same. Okay, draw. Agashi phone ille. Adil photo എടുത്തിട്ട് draw ചെയ്യ്. If you don't have textbook, take a photo. Royden, you have phone. Yeah. Take a photo and draw. Yes.
Run the beach. Run the beach. Yeah. Run outside of this. This harmonic. This is bad, yeah. This is harmonic or something. Okay, I want to know. You will draw that.
Yeah.
Fundamental.
This is first mode of vibration, second mode of vibration, first mode of vibration, second mode of vibration, third, fourth, fifth, sixth mode of vibration. And this is known as fundamental frequency. Fundamental frequency or first harmonic. First harmonic. This is second harmonic or first overtone. Third harmonic or second overtone. Fourth harmonic or third overtone. Fifth harmonic or fourth overtone. Then sixth harmonic or fifth overtone. The names you should be thorough. Okay, copy the diagram. Copy the diagram, okay.
Let him feel it one day. You don't cut it. You don't drop it. You cut it. You have to shush. Then take your phone. Please. Please. You three. You need this dog like that, man. When the kids touch the ground. You're a critical. You should, then you will be understood by other audience. Look at the other side there. Look, he wants it. Hello, right? I can't be. He's photo. Mine black shit. What is this? What is this? What do? Okay? No. Can I take? No. You're too far. What is my overtone?
That's just the name. It's a name for the frequency of that particular mode. First harmonic frequency or no, first harmonic or fundamental.
And what makes an overtone?
Second harmonic frequency is known as first overtone frequency. The name of the frequency that. Okay, finished, right? Finished? No. What you were doing? Oh. If I go, your mouth will start writing.
What does else? I didn't see that as a part.
Oh, you didn't see.
That is, that's it. That's it, yeah. The more. Is it someone who is I think I'm good, bro.
Okay. So. Okay. So listen, I told you, we have to study 3 cases. Stretched string, open pipe and closed pipe. Okay. I will explain stretched string, this one in detail. Then you will be able to do the other 2 easily. Okay. So I'll explain. Our aim is to find, listen all of you, this is easy. If you understand, this is easy. So, we'll find, first we will write about the first mode of vibration. For doing all these 3 cases, for doing this, we just need one formula. That is, frequency is equal to velocity by wavelength. You know the formula? Frequency is velocity by wavelength. Velocity is equal to nu lambda, you know. Okay, so we just need that formula to do the entire thing. That is velocity is equal to nu lambda or nu is equal to velocity by lambda. Just this formula is enough for doing the whole derivation. Our aim is to find this nu. Our aim is to find these frequencies in terms of velocity and wavelength. Okay, okay. So first, it is first mode of vibration. First mode of vibration. In first mode of vibration, what is L? Can I write L is equal to lambda by 2? What is lambda? Listen all of you, what is lambda? Wavelength. So here, this is actually half of wavelength only. Wavelength means this is full lambda. This is full lambda. In the first case, in the first mode of vibration, this much only, right? Lambda by 2. Understood? So in the first case, L is lambda by 2. Okay? Second case, what is L? Full wave is there. In second case, L is lambda. In third case, what is L? Lambda plus lambda by 2. 3 lambda by 2. Correct? In the third case, L is 3 lambda by 2. What about fourth case? Lambda plus lambda. L is 2 lambda. That you should know. Okay, from the diagram, you can easily identify what is L in terms of lambda. Okay, now next step. The first step you will write in the first mode of vibration, L is equal to lambda by 2, lambda 1 by 2. First case, right? So lambda 1 by 2. Now what is nu 1? Nu 1 is velocity by lambda 1. So velocity by what is lambda 1? You will get lambda 1 as 2L. 2L. That is nu 1. Nu 1 is equal to V by 2L. Understood? That is the fundamental frequency or first harmonic frequency. Listen, I'll give you time for writing. Understood? Now, second mode of vibration. Okay? So, first mode of vibration is done. Now, second mode of vibration. What is L? L is equal to lambda. Correct?
Yeah.
Now, what will be nu 2? Nu 2 will be equal to V by lambda 2, V by L. I can multiply divide by 2 in order to get it in this terms. 2V by 2L I can write. This is V by 2L. So this will be, in order to get in this term, I will multiply denominator and numerator with the 2. Correct? So this will be 2 times nu 1, right? Understood? Okay. So that's why this is known as first overtone. This was the first harmonic. This is second harmonic or first overtone. This is first overtone. 2 nu. Okay. Now when you find for third, we will do up to 3. Okay. The rest you will be able to do. So third mode. First step, what is L? L is 3 lambda by 2, right? Or lambda 3 is what? 2 L by 3, correct? Correct? What is nu 3? Nu 3 is equal to V by lambda 3. That is V by 2L by 3 or 3 V by 2L. That is 3 nu 1. Correct? Okay, so that will be the third harmonic or second overtone. Okay, so what is the ratio of all these frequencies here? Nu 1 is to nu 2 is to nu 3 is what? 1 is to 2 is to 3. Okay, so that is the first case. Here, nu 1 is to nu 2 is to nu 3. It follows, okay. It's 1 is to 2 is to 3, etc. Understood? So this is the first. So our first thing what you will do is diagram you should be thorough. The diagram you should know. Okay. After drawing the diagram, find L in terms of lambda and substitute nu is equal to V by lambda. That's it. Okay. So take down first mode of vibration, second mode of vibration, and third mode of vibration. Complete that. Understood, all of you? Megha, are you there?
Yes, ma'am.
Finished, all of you? Now next you give heading normal modes in a closed pipe. Normal mode in a closed pipe. And copy the diagram in the textbook. 6 diagrams, closed pipe diagram. That is A, B, C, D, E, F, those diagram, okay?
Closed. Pipe.
Normal mode in a closed pipe. This one, okay? Closed pipe. 1, 2, 3, 4, 5, 6.
Let me see it. Ma'am, which diagram?
Normal mode in a closed pipe.
Taking picture. No.
You didn't get the diagram? The next one after what we have drawn. Yeah, that one. Yeah. Pranav, you didn't get?
No, which page number?
Turn the page from where you stopped. Till you didn't get? Pranav?
It's the mu. Yeah, there.
Oh, those 6 diagrams.
Brother, what is the thing? I mean, only thing we are. Go ahead. Make it a new wallpaper. Not my face. Come on.
Go ahead and draw.
That's nice. You drop from it. Yeah, there's no second harmonic, there's the third harmonic. So we are talking about what I'm drawing. Yeah, exactly. Yeah, that's good. When you're drawing like this, it's not really that hard. Oh, Lord. What? The picture needs it inside. I know it.
Okay, finish, right? What you are doing?
He's cutting everything off.
Okay, normal modes on a closed pipe.
Job, Steve. Finished not?
Broider, you finished?
Yeah.
Who has to finish? Me. Akash, you finished? Do. Right? You have to learn drawing. Huh?
Didn't see anything. Didn't see anything. Yes, did anything happen with that? Did anything did anything happen with that? Nothing happened. Yeah, see nothing happened. Yeah. Nothing. I picked this. That one in Zoom suit, yeah. One across the chin.
Finish, right, all of you? Okay, same method, but the name is different. All modes are named the same. First mode, second mode of vibration, third mode, fourth mode, fifth mode of vibration, sixth mode of vibration. That is the same. And fundamental frequency or first harmonic. Then here you will have only odd harmonics. First harmonic, third harmonic, fifth, seventh, ninth, 11th. Why? Because the previous case, second harmonic was 2 new one, third was 3 new one. Here in the second mode you will get 3 new one. This will be 5 new one, 7 new one, 9 new one, 11 new one. You will have only odd harmonics. That's what. So this is first mode. And the frequency you will get now, name it as fundamental frequency or first harmonic. What is L here? What is L here in terms of lambda? One full wave is lambda. Half of that is lambda by 2. This will be lambda by 4. Only this much you have, right? So here L is lambda by 4. Okay. Lambda 1 by 4. So lambda 1 is 4L. So what will be nu? V by 4L. V by lambda 1. V by lambda 1. That is V by 4L. That's it. Understood? Now here what is L? So this is second mode of vibration, or you will get third harmonic. What is L here? Lambda by 2 plus lambda by 4, right? What is that? Lambda by 2 plus lambda by 4. What is that? 3 lambda by 4? 3 lambda 2 by 4. Or lambda 2 is what? 4 L by 3. Correct?
Yeah.
So, nu 2 will be equal to V by lambda 2, that is V by 4L by 3, or what you will get? Nu 2 is equal to 3 V by 4L. This was V by 4L.
Yeah,
This will be 3 V by 4L. That's why it is known as third harmonic. Understood? Now do this also. Do the third one. So what will be L here? All of you tell me. This is lambda by 2. Akash, what is this lambda by 2? What is this? 4. What is that? Lambda by 2 plus lambda by 2 lambda plus lambda by 4. How it will be? 5 lambda by 4. So L will be equal to 5 lambda 3 by 4, or lambda 3 is equal to 4L by 5, or nu 3 will be equal to V by 4L by 5, or nu 3 is 5V by 4L. Correct? So what is the ratio here? Nu 1 is to nu 2 is to nu 3. 1 is to 3 is to 5. Here nu 1 is to nu 2 is to nu 3 is equal to 1 is to 3 is to 5, and so on. The same will follow. That's why we are not doing the rest. Iron, you understood? Then previous one you understood. Here what is the doubt? Where? What?
Second mode having a third half.
Because it is 3 times the first. V by 4L is the first. In the previous case it was 2 times. Here it is 3 times. That's why. In here you will get 5 times. Understood? That was the doubt. Jessica? What? Understood. John understood. Adarsh. For those who are online, if board is not clear, I'll send the photo, okay? Dan finished? What dairy milk? Finish? Finish. Next you write open pipe. So closed pipe is done. Next is open pipe. Normal modes in open pipe. That is the heading. Normal modes in open pipe.
The diagram for this too.
Yeah, draw the next diagram. Open pipe. The 4 diagrams.
Your book is almost done. Almost.
Draw the next. I'll share the screen. Normal modes in open pipe. Yeah.
What?
Megha, the previous one I've shared the board, okay? I have shared in group in WhatsApp. Complete that, okay?
But that's it, all.
Next is normal modes in open pipe.
Now draw faster. Oh God. Just this.
Okay. And try to do the same what we did before. The name of this one and the previous one is the same, okay? Name is the same for first and third naming is the same. First and third naming is the same.
Yeah, this is close enough.
Okay, now it's
Yeah. Did it? 1, 2, 3, 4. Actually. Okay. Is it more like application?
Finish doing?
No.
Aaron? Finish.
No. Yes, it is. I think yeah, so simply, yes, no, the new, yeah, 18, old, 22, older, 23, 30, no, 24, 36, older.
What game you're playing?
Guessing your sister's age.
Your sister's age. 21.
Older guy. 98. 27. Why did you mean? I don't know. Yeah, okay. Why? I don't know. Okay. You know, the older brother too. It's in India. She's going to be engaged.
Okay, finish, right? Zia out in the record.
I don't know.
Okay. So the name is, this is the first mode. First mode. First mode, you will get fundamental frequency or first harmonic frequency. This is the first mode. You will get fundamental frequency. Or first harmonic. What is L here? What is L here? What?
Yeah.
Lambda by 4. Lambda by 4. What is it? Lambda by 2. Lambda 1 is equal to 2L. V is equal to nu 1 by nu 1 is equal to V by lambda 1 or V by 2L. Nu 1 is equal to V by 2L, correct?
Yes.
So here, what is L here?
1 second.
Huh? What is L here?
3.
Lambda by 4, lambda by 2, lambda by 4. What is it? Lambda by 2. Sorry. Lambda. Lambda, right? Lambda by 4 plus lambda by 4 is lambda by 2. And this plus lambda by 2 is lambda. Right. L is lambda. So nu2 will be equal to V by lambda, V by L. Multiply, divide by 2. 2V by 2L. So that is what nu2 is equal to 2 nu1. Correct?
Yes.
Correct, right?
Yeah.
Now here what is lambda? L is equal to 3. Lambda plus lambda by 2 is what? 3 lambda by 2. Lambda is equal to what? 2L by 3. So nu3 is equal to V by 2L by 3 or 3V by 2L. Understood? Easy, right? So nu1 is to nu2 is to nu3 is what? Nu1 is to nu2 is to nu3 is equal to 1 is to 2 is to 3. ഞാൻ വല്ല മനസ്സിലാവുണ്ടോ? ഏ? എന്ത് buy to get one free യോ?
Yeah, enjoys it.
I actually forgot to message her. I added in group now. The last class she came, so I thought she's there.
Text me together. She asked us to go together.
She asked today no, because she thought it is in the afternoon. I added. Still sleeping, I think. Not seen yet.
What's
But
free?
even if she sees the blue tick won't come. Her settings is different.
You do? Sure. Room with the name. Why? You have it now. Now you add me. Yeah.
No, which group is what I'm thinking, this or the other. Anyway, after vacation, you will be online. So which one you want, anything is okay. During vacation only this one, so I'll put it in this itself.
Last reference.
So during vacation, let you come like this. After that, we will see. After the vacation, this batch is free. Next week only. Next week also you come like this. After that, first week. Finished all of you? If you're attending online, better to attend with the other batch. Peaceful. Eh? Finished? All of you finished? Yes? Okay. Finished, right, all of you? Clear? Now there is one more topic in this chapter that I'm not taking now. That I'll be teaching you after the school teacher teaches you. The topic is beats, okay? Because in some schools they will just give the definition and equation. If derivation is taken, it is a 2-page derivation. So I'm not taking now. In which school, in Addis they didn't take. They just gave the explanation and equation. We will wait. If that much only, no problem. Just equation and definition. If they are taking derivation, means they will ask that also. So we will wait. If teachers teaches the derivation, like that is the last topic, right? So they have to rush. If they are teaching that, means it is there for the exam. So we will wait whether teachers teach, that time I will take. Remind me, okay?
Yes.
In this chapter only beats is missing. Beats has to be taken. So now fluids test will be there on Tuesday. And for sunrise students, I didn't teach fluids portion. You were absent.
You can teach them first. No test.
Huh?
No, teach them first.
I will teach them, no problem. Okay.
So,
Monday morning, you will be all, you all will be.
Nice. Monday evening they're free. Maths tuition. Maths tuition.
അപ്പൊ 10th and 12th തീർന്നോ? Next week they don't have? No, they have in the morning.
Monday evening we are free. We can take.
Monday.
Yeah, the morning.
What? Max is in the morning. Max morning, Max, you are,
Yeah.
yeah. It won't be in the morning because,
Maths is fine.
morning I will take.
Yeah, exactly.
What happened? So morning, just remind me, okay? Sunday students fluid chapter. I'll take. There is a derivation Bernoulli's. I think that one recording I have. It's a big derivation that you watch. Okay, I'll explain in class, but you watch and complete the notes of Bernoulli. Remaining I'll take in class. Okay. Okay then. Hey, everyone is leaving. Okay, bye. Bye.
Thank you, mom. Bye.
So start studying, okay? Fluids.